Hello everyone, my name is Ricardo Neves and I'm making a Java tutorial for beginners where you should attend if you don't know anything about Java or even about any programming language. This will be very helpful for you to understand the basics of Java, and this tutorial will be split in 4 sessions. So, session 1. Most important, set up your Java environment, install the Java JDK so you can develop with me and learn with me. Next, you will need to install an IDE. There are many IDEs available, Eclipse, NetBeans, or IntelliJ, or even if you don't want to use any IDE, that's okay. Then you learn how a Java program is formed. You'll learn its anatomy. You'll understand what are the building blocks of a Java application. Next, we'll go to the fun and write the hello world, the typical hello world for a Java program. And then you'll need to learn how Java code is executed and how it can be different from another languages like C or C++, and how it can be similar, for example, with Python. You finish session 1, you know how to write an hello world, that's okay. And then session 2, we'll learn what are the differences between primitive and reference types. And since we will already know what classes are, we will explore the string class, which can be really helpful and is like a really used class in Java. And then we'll explore arrays. And that's it, you finish session 2, and let's go to session 3, where we are going to start exploring arithmetic expressions, making sums, subtractions, divisions, and other types of arithmetic expressions and operations. So after that, we will explore the math class. This has another built-in features apart from the arithmetic operations that you learned before. And then we'll stop and learn about logic operators. Those are the building blocks for any programming language, and it's like the AND and the OR logic operators, how you should use them, and how helpful and useful should or they are for programming. Last but not least, session 4, let's learn about if statements, switch statements, for loops, and while loops. There are a bunch of other loops like do while, for each, but let's go with the basics. You will learn the basics, and from here you can explore another kind of loops and decide whatever it's the best for you. And that's it, my friends. So I hope you, if you like this presentation, if you think you will learn, I know that you will learn, just click next, go to the next presentation, go to session 1, and I hope you have fun. Goodbye. Hello everyone, and welcome to session 1 on tutorial Java tutorial for beginners. So this is the first session and already presented to you what we are going to do. Let's now take another look at session 1. So session 1, we are going to learn how to set up Java environment. This includes installing the JDK, which is the Java Development Kit. After that, you have everything you need, almost everything you need to develop your Java application, but you also need an IDE. So I will choose IntelliJ. We are going to work with IntelliJ, but you can choose whatever you want. I also recommend Eclipse or NetBeans, or if you are an hardcore programmer, you can use a text editor only. Then we will understand the anatomy of a Java program, its structure, and the basic write a basic hello world, and after that we will learn how the Java code is executed. This is important so you understand how it works and why Java might be different from another or other programming languages. Okay, so let's go ahead and start doing this. So first of all, let's set up the Java environment. So you just need to type on Google JDK download. Okay, let me put this bigger so you can see, and you can enter in the first. What can you see here? You see that Java is on version 18. That's okay. And now if you are on Linux, you choose whatever you want. The distro might be different, so you might need to choose a different binary. If you are on Windows, just choose one of those. You can choose the MSI installer or the x64 installer or even compressed archive. They will all do the same. And if you are on Mac OS, just choose the DMG installer. If this one is for M1 Macs and this is for Intel based Macs, so choose whatever you want. I already installed JDK, so after you finish installing JDK, you can open up your terminal if you don't have, if you want to really confirm if you have it installed, and you just need to type java -- version, and you see here it will have a version of, it might not be really like I have it here because it is OpenJDK and is version 11, but if you don't have any input or you have command not found, it means that your Java is not installed. Otherwise, you are good to go. Okay, after that, we need to set up our IDE. So let's choose, I choose IntelliJ, so IntelliJ download, and you click the first one. There is a community version which is free, and basically you choose whatever operating system you are on, and it will choose the right binary. So just click download and install it. Good to go. Alright, IntelliJ is opened. Now you click create new project. Java, you don't choose any of this. It might be different. Notice that I have Java version 11. You should have the 18 or 19. You should click next. Now we can create a Java Hello World, which will have already the Hello World, or a command line application. Let's go for the Hello World. And the project name will be Java Hello World. And you hit finish. Yes, I already had one, so it will create your Java application. And now, all right, so what we have here. Okay, this is the basic structure of a Java program. And this might be strange for you. Why do you have a class? Why do we have a method? I will try to guide you on this journey. So if we run, let's see if it's working. So you can click in this debug button or the run button. Debug, you can do breakpoints, but you saw here hello world. If you click on run, is the same thing. Okay, hello world, you see here. So you should see the same thing in your side. Okay, so now let's focus on this right now, and I'll try to tell you what everything means. Okay, so let's go from the beginning. Public. Let's forget this for now. This is called a method. Okay, this is a method. Okay, and you might call methods. Imagine a method in Java is called a method, but it can be a function. And what it receives arguments that have a type, okay, and a name, okay. And this is the method name, which is main. This is the return type of the method. Void means that this method doesn't return anything. And you have here the instruction inside the method, which is system.out.println hello world. This might be strange for you as well. In this case, system is a class, out is a parameter of that class or a member of that class, and println is a function just like the main function, but it's called println, okay, and receives as an argument a string, which is the hello world, okay. So for now everything might be more clear. Now you might see, let's focus on public class. So you have a public here, you have also a public here. Public is the method or the class visibility, and don't worry about this, but there are public, okay, which mean it's visible for every across the project. You might have private, which means it is not visible outside the class, it's only visible inside the class. For example, if this method was private, nobody outside the class should be able to access it. And also there is another one, which is protected. Don't worry about this one. This is a different scenario. It's based on the inheritance, so don't worry about this. This is not important. This is not a big deal. Just so you understand. And then we have the keyword class, which defines a class. And then you might see that this main and this main are written in a different way. This starts with an uppercase and this doesn't. And it might be strange for you. So now it's just naming conventions, okay? So it doesn't need to be like that, but it's naming conventions. And this main here has naming convention of camel case, in which the first letter is a lowercase, and you separate words by having an uppercase here. So if this method was called main method, it should be written like this. It should be written like this. Okay? And the class name is this main, right? You might notice that it is different. So it means that it is written in Pascal case, which means the first letter is uppercase and the letter that separates the word is uppercase as well. So if the class was called main class, you should type it like this. Okay? Both are uppercase. So far so good. Classes are used to organize our code, and you in normal Java program have lots of different classes. In this case, this is only a simple method and a simple program, so you don't just have one class, but you might have like thousands or lots of them. And like I said, every class might have different parameters and might have as well different methods. In this case, we just have one method here. So, okay, so now you might trying to understand how does the Java program works. So there are several steps so you can run your program, and let me talk about them. So when you compile, so you have your code, so you have one box with your main.java, right? Which is this file, right? So you will have a compiler, okay, and a compiler is called javac, and this compiler will transform this main.java, which is our source code, will transform it into bytecode. And this bytecode is a code that Java Virtual Machine, or JVM, will be able to understand. So you compile it, and now you have bytecode. You can call it as well machine code. After that, this is your executable file, but it needs JVM to work with it. So inside of it, it will be inside of your JVM, which is an acronym for Java Virtual Machine. And this Java Virtual Machine will be an executable which will be running on your operating system. It can work with Linux, with Mac, and with Windows. Okay, it can also work with Solaris, but let's focus on these ones. And it will understand this code. But the JVM needs to talk with operating system. That's why you have different JVMs for each operating system. And as you might know, or you maybe don't, Java bytecode can be executed in all machines because you have JVM that translates the bytecode to machine code. And machine code is code that Linux understands, Mac understands, and Windows understands, and Solaris understands. But machine code is different for Linux, for Mac, for Windows, and for Solaris. So JVM will transform this bytecode into machine code for each operating system. JVM for Linux will translate this code for Linux. JVM for Mac, and JVM for Windows. You might get the point, right? So, as you might see, you have your JVM that will, when your Java program is running, it will transform this bytecode into something called native code. And this is good because with only one Java code, you can run it wherever you want. You don't need to write a new code to run it in another platform. So, as I said, this will be good for Windows, Mac, Linux. And this is one of the great features of the Java and Java Virtual Machine, because the code, this code here, we can say that this code is portable. It can work in whatever you operating system you might need. So let's try to compile this code. So to compile this code is really easy. So let me open up terminal. Okay. We are inside the project. And now we have a compiler called javac. Okay. If you don't have this output, something is wrong with your installation. And we can compile this program. So if we run javac and source main.java, if you see, there is an out folder here. So if you go there, and if you go to production, you will see, and if you go to Java Hello World, you see a main.class. This main.class is our bytecode. So this is .java. This is .java, this first one, and this is a bytecode, is our main init.class. Okay, this is not human readable. Sorry, this is human readable. You can read it, and it is understood by the. It is actually being decompiled, but it should not be human readable. If you open this with another editor, you might not be able to see the content. This is decompiling the file. So we now have the bytecode, right? But now we need to run it and create native code. So we use the Java-C. Now we can use the keyword Java, and we can just do Java main. Okay, we are executing our bytecode inside our JVM, which will translate that to native code and run our code. So now you see an hello world. So this step just happened and it translated to native code for Mac. I'm running Mac, so it will run the program in my machine. If I pass you this file and you are using Windows, you will also be able to run. But your native code that JVM creates will be different from mine. So this is those are the plus of the Java programming language, is that it is portable and the same code works for every other operating systems. It's session 1 is complete. You now understand how a basic structure of a Java program is. You now understand what is being done here. And let's go and skip this to session 2. So you might want to stick with me to learn a few more things about Java. See you in session 2. Hello everyone and welcome to session 2. I hope you are well. So session 2 will be about, we are going to talk about primitive versus reference types. This is a big deal in Java. They are very different variable types, and it's important that you understand the difference. And if you don't know the difference when you are developing, some weird problems might occur, which you don't want. So stick here to understand what are the differences between those data types. We'll also explore the string class, which it's a reference type, okay? And we also explore a little bit of arrays, which will store like a collection of objects or a collection of primitives, just like this. So this is the plan. Let's go and start working. So as you might see, you have here our main file, which has everything we need for now. And I forgot to mention that this string args is a string array, so it might be something like this. Okay, and this means that it's arguments that you might pass to your running Java program. So you might pass how many hello worlds you want to print, for example. Yeah, so now you know what does this mean. And this signature will always be present in every program, a Java program. So it's mandatory that you have this here. So you might be asking, so what's the difference between primitive types and reference types? Let's go more slowly. First of all, let's speak about primitive types. You have byte, you have short, you have int, long, float, double, char, and boolean. And as you see, byte, you can store until 1 byte. So you have 8 bits there. You can store whatever you want. So then you have short, and this is the range of what you have. So the maximum of this is 2 at 15 minus 1. And as you see, integer is almost same thing, and long, but they have higher maximum and minimum, so they have a longer range of values that you might use. You also have a floating point, which can hold decimal numbers, and the double can also hold decimal numbers, but a lot bigger. And also double versus float are almost the same, but double can handle a wider range of values, and also takes more space. It takes 64 bits. Then we have a char, and the char takes 16 bits, and is like a single character. So it might be a letter, a number, a symbol, but just one. And then we have the boolean, which is true or false, and it takes 1 bit. So let's play a little bit with these variables and see how they work. So first of all, you define the data type. Okay, so int, you see when I type t, it goes orange. It means that it is a reserved keyword. So you cannot name an int int. An int cannot be named int because it's a reserved word. So you might have like int age equal 30. So what I'm doing, I'm assigning the value 30 to this variable, and it will take 32 bits. We can also have like, this can also be stored in a short. It will also work. And as you see, the short is 2 at 2. Let me change here. So 2 at 15, 32,768. So if I see, I get an error. What does it mean? Incompatible types. Requires short, you have an int. Why? Because this value doesn't fit a short. So our IDE is smart enough to know this is not right. So what do we want to do? Migrate age to int. Okay, now it fits. So it's just, you can see the different sizes in our variables. You can also as well like have a float, okay, which is a decimal number, which might be your height, for example, in meters. So your height will be 1.7 meters. And you see, this is not right. So it says that it should be a double. What happens if you change to a double? Oh, it works. But it should work with a float, right? This happens because in Java, when you say 1 dot something, a decimal number, it will always be converted to a double. So there are some ways you can fix this. You can do this, and this is a cast. You are saying, no, this is a float, trust me. But there is a smarter, a smaller way or a simpler way of doing this. You just type F in the end, or uppercase F. I recommend you to write uppercase F because F is similar to 1. So F. So now you have a float. Great. We can also have a char letter, and it's your first name letter. So first name letter. See that I'm using camel case here. So first name letter might be R, and you might be, what happened? So it says it found a string. Why is that? If we change this to string, it will work, but you don't want it. You want a char. So to be a char, you don't need just need to use this symbol here. So it's different. A char always is like this, and a string is always like this. Great. Now let's make a program that will print your age. Okay, so let's also see a boolean. So are you male? And the boolean just false or true. Nothing more, nothing less. So let's print our age. So you can print like, so you see that this print line, if you see that, let's go back. If you see that it receives a string, I think you can see there. So we can concatenate strings. So you can see, say, my age is, and now you give a space, a plus, and now you just put your age. This program should print your age. Why this age variable is different from the other ones? Because our IDE is smart enough to know that those variables are not being used, so they just don't need to be here, okay? You can also, if you don't need it here, you can comment your lines. When you comment, the compiler will ignore those. So you can do // and it is commented. So this code doesn't matter. Compiler will just ignore it. If you want to comment something, you can just do this is the age, and you are saying that, informing the next programmer, or maybe you, when you're reading the code, it might be clear for the people that are reading the code what this variable might mean. In this case, it is self-explanatory, but it might not be. So let's comment out this code. We can comment line by line, or we can comment like this. And it will comment everything down, and then we do the reverse, and it will comment everything up. So you end up with everything commented. We can run our code again by running javac and then java main. I can do it for you if you want. So java, we need to go back. Okay, so now we just need to go to source, and let's see if our main class has what we want. Main Java has what we want. It has. So let's just do java c main.java. It's compiled. So now we have the bytecode. Now we just need to see where our bytecode is. And our bytecode, as you saw earlier, is on out production Java Hello World. So we just do cd out production Java Hello World, and just do java main dot class. Sorry. So now it just can compile it. So javac main.java, it is compiling it. And now if you see, you have a main.class here. So you can just do java main, and that's it. You will run your program. So your age is 60,000. It worked, right? So now I'm trying to, so we spoke about, we spoke about primitive, let's speak about reference types. So what happens if we do something like int age and int age 1 equals age? You might. And now int age, and now we change age to be 3. Okay, and now it's 4. Okay, Great. So, what do you think will be the values? So, if we print age values are, and we print age 1 and age and we print age 1, okay, age 1, what do you think it will print? Because we are making age with 4 value, then we are saying that age 1 will be equal to age, so it will hold the 4, right? And then we are changing up age again. So age 1 will have the 4 or the 3. Try to guess it. Now I'm not going to run by running Java, C and Java. I'll just click this button that will do those 2 steps together. Let's see what happens. I forgot the space, sorry. Wait a second. But you also see the result, right? Let's run it again. Of course I need a space here as well. So, let me try to zoom in here for you to see. And it says age values are age. So age has value 3 and age 1 has value 4. So this means that every, now it's a little explanation. No, okay. So for you, this might be okay, but some other languages doesn't work like that. So imagine that you have your memory here, right? This is important for you so you can understand, okay? You have your memory here, right? And imagine this is a position of memory that fits one integer. So imagine that your age variable is being stored here, which is 4. When you create the age 1 and equal to age, what does happen? A new position in memory is used called age 1, which will hold the same value as age, which will be 4. So far so good. When we change the age back to 3, what will happen is this will be no longer 4 and we start being 3. That's why you have this print 3, 4. This makes sense, right? But this only works for those primitive types. Let's try to work now with a reference type. Okay? And reference types are a different scenario. Let's delete our code. Let's comment. And let's create a reference type. So, point. This is a Java class from Java AWT package. Let's instantiate this point. So, it's a point. The type is point. It's a point 1. And now we create an object. So, we use the keyword new point. And now we can see what it receives. It receives nothing, and it will create a point with 0, 0. But it can also receive a list of coordinates, x and y. So let's create, and you see the x and y are integers, or ints in this case. So the first point will be 1, 1, right? And now we create the point 2, which will be, actually, let's not create a point 2. Let's create a point 2, which will be equal to point 1, right? We are doing the same thing that we did here. But now, let's do point 1. And now, the class point has two parameters, or 2 members, which is the x and y, okay? And what we are going to do is change this parameter on the point 1. So point 1 dot x will be equal to 2. Okay, let's make something now. So system.out.println, and now print the point 1. This won't have any surprises, I guess. It will have the values of x will be 2 and 1 because we changed the value of x here. Let's execute it and see the result. So let me zoom in. As you might see, x2, y1. Makes sense, right? What do you think will happen to the value of point 2? Do you think it will be 1, 1? Like in this case, the value of age 1 was 4. Let's see what happens. So, point 2. They are the same. And now you might be thinking, oh, they are called reference types. Let me tell you what this means. So we have here the example of the age. Now let's see the example of those points. So points are variables, and let's go in the simplistic way. Right? They are variables like the other variables. They just take up more space. And when you declare a point 1, you declare something like this: 1, 1. Great. And this will be point 1. Okay? But now, when you say that point 2 is equal to point 1, if it was a reference, if it was a primitive type, you will just do this. Create a new memory position, and it will be point 2, right? But those are reference types, so that doesn't happen. What happens? This is wrong, okay? This is completely wrong. What happens is that you do something like this. Oh, this is the same, so why wasting memory? This is the point 2. So they are pointing to the same memory position. So when you change this point 1, you are actually changing the same memory position and not same variable, but same memory position. So when you change point 1, it will affect point 2. And when you change point 2, it will affect point 1. So that's the big difference between primitives and reference types. Okay? This is really important so you understand this. Otherwise, errors might occur. Now that you understand the difference between those, let's explore a little bit of the string class. So, the string is a reference type. So you might see this, I didn't talk about this, the import. So we can import like this, and it will import everything inside this package, and we can also import like this. It's the same. Here we're just importing what we need. Here we're importing everything. Okay? Let's speak about strings. So, how to declare a string? String A equals A. Okay? But string is a reference type, and how I created a point, I did point A is equal to new point 1, 2. I did this, right? So they are not being instantiated using the same methodology, right? Since a string is a class that is used lots of times, this is a shorthand and a shortcut for this. Sorry. It's the same thing. Okay? But IntelliJ says, no, this is redundant. You don't need to do this. Just do it. This is normal way. You can do it both ways. So, string is a reference type. Okay. So it works like this. When there is a reference type, it might have different methods and different parameters. So if you see hey dot something, some methods appear here. But if you declare an int, if you do b dot, nothing appears. This is not like methods. So let's see what we have here. So we have the starts with that. Now you can see what it does. It receives a string and returns a boolean. And tests if a string starts with a specific prefix. So you might be guessing what it does. So this returns a boolean. So we can just do boolean results is equal to this. It works, right? And then we can just do system out. This is a cool shortcut result. And you might guess this will be true because it really indeed starts with S. Let's run it and see. True. But we make it a T. It will be false. Makes sense, right? We have also the length of a string, and a length of string is like number of characters that it has, including the white space. So a dot length, as you see, it doesn't receive anything and returns an int. So just need to change this, and unsurprisingly, it will be 1, 2, 3, 4, 5, 6, 7, 8. It will be 8, the result of this function. And it is. So this might be used for you to validate, for example, a password that has a minimum size. We can also use the trim. And the trim, as you see, will return a string and we won't receive any parameter. So we just need to change this to string, and unsurprisingly, the result will be the same. But let me tell you what trim does. The trim trims the string. It means that it removes the white spaces that are on the beginning and at the end. So if we do something like int size or length is equal a dot length, and then we just trim it, create another string and another length, new length, and now we print the length and also new length, you might okay, will be from the result, of course. So the length of this one will be 10 and this one will be only 8. It will be only this. If we run it, let's see if it makes sense. So yeah, 10 and 8, because this trim removed the white spaces from this this string. And just to conclude, we also have a method called dot. We have much more, but we have index of that receives a character. So let's put a T So, and indexes start by 0. So this will be index 0, 1, 2, 3, 4, 5, 6, 7. So it will return 0, 1. It will return 1. So index, it should return 1. Okay, if we put a letter that doesn't exist, like X, let's see what happens. It returns -1, and you might say, why? When something doesn't exist, it goes -1. But if you don't know, you can go to, this is called Javadoc, and you can see here, it returns -1 if the character does not occur. So you have documentation for doing what you want to do. Now let's speak a little bit about arrays as well. So how to declare an array? So int numbers will be equal to new int of 5. What does this mean? This means that you are creating an array that can store 5 values. The length of this array is always 5. You cannot make it bigger or smaller. When you create an array, it will be at a fixed length. If you possibly don't want to create an array because this is really limitative, there are many other classes, but there is an interface or a type of list, and inside of this you have something called array lists, which you can actually add elements and remove, and it will dynamically increase or decrease its size. But we won't talk about this one. Let's just talk about this one, which is really simpler, and it's the right way of learning how to deal with arrays. So we have number, and how can we work with that? So we can do like numbers, and now index 0 will be 1, okay. Index 2 will be 2, 3, for example. And now let's print the array. Hello everyone and welcome to session 3. So today I hope you enjoyed session 1, session 2, and today we are going to speak about arithmetic expressions. So you already know what that means, so we are going to speak about the add, subtract, multiplication, division, and maybe the remainder of division. Okay, so then we are going to explore the math class. So this is a class that has some utils that you can do beyond those operations. So we have in the class in the math class, for example, a method to generate random numbers. We have the ceil method. We have also the floor, which is, you'll see what it is. So we have some methods to show you, and the possibilities are really endless. The math class is a really complete class to make basic and a little bit more advanced operations, and you'll learn how to use it. This is a built-in class in Java, so you will have it without importing any external library. And then we are going to look at logic operators, and this is a big deal. So we have the plus sign. Sorry, we have the logical OR. We also have the logical AND, which is the something like this. It's a commercial E, and that's basically it. So we also have the NOT, which negates, but yeah, those are the logical operators, and they always return a Boolean value. So they return true or false. Nothing more, nothing less. So that's basically what we are going to speak in this class. I hope you guys stay there, and let's go to the code. Okay, let's go to the code. Here we are. Let's delete this from the previous lesson, and let's start working, right? Okay, so division, right? So we create a variable integer result, which is equal to some division. Imagine 10 divided by 5. What do you think it will be? It should be 2, right? Let's test it. So result. Awesome. So let's run the program and see what we have. It should be 2, and I think it will be 2. It has to be 2. Great. But now let's do some more advanced stuff. 10 divided by 3. And if we do 10 divided by 3, we know that is 3.3333. But this is an integer, so it doesn't fit there. So, okay, it just goes to the nearest one, which is 3. Okay, makes sense, right? But now imagine that we do this. It should have space, right? Let's test this out. 3. What's the problem? So the problem is that the normal, this is like called integer division, so it always gives you integer results. If you want to make it not integer, you might do this double, because you're dividing two integers, so the result, Java says that the result needs to be an integer. But if you do this, right? If you cast both to double, Java say, okay, those are doubles, so maybe they either you don't want an integer, so it works. That's good. Actually, you only need to cast one, so Java knows this is not integer. So that's like something weird in Java, but that's something that you need to be aware of when using this. So what we are gonna do next? So you know division, but I can talk to you about the plus sign, for example, but you already know what it will be the result. This is pretty obvious. And I don't think we need to be learning this. You already know arithmetics, you already know what it works, so you know the result and it's easy to predict. So the only strange thing was that division sign, so you already know, and we can go to the next. So now imagine that you have this result and you want something. Normally you want to increment something. Normally in loops you need to increment a variable by 1 or by 2 or by 3. So there are several ways of doing that. So int incremented, and you can do this result plus 1, and actually result plus 1, and if you print incremented you'll get, let's make it more simple, so it will be a 10, so you know you'll get an 11, right? That's awesome. But now imagine that this is quite complicated, right? So you can also do something like this, result, and you can do result you can do something like this. Wait, and you might be thinking, what it does. So you don't need to declare an integer, of course, and you see this and think, so you're having a plus plus, so are you adding 2? No, you're adding 1. So this is increment, but you also can decrement it with this operator. So in this case it will be 9. Easy to understand, right? You can also do something like this. You can also do something like this, right? And you might be, that's the result, right? Yes, it is. It will be 11. No, it's not. And you might be wondering why. Because this is a post increment operator. You can increment it before or after. So only after the execution it will be incremented, right? So if you now after that print the result, you should have 11, you should have 10 and then 11. But if you do something like this is not valid, of course, and you do something like this and you remove this, you'll have immediately an 11 because it increments right away. It increments right when you declare it, and the other case it increments only after calling it. Those are two different options that you might have, but yeah, those are different, but they are always almost the same, but they have different use cases. Okay, so that's basically it for increment and decrement operators. You can also do something like this. So just to finish this off, you can do result plus equal plus equal results. And what does this mean? Let's print results. What do you think it means? It will be 20. Why is that? This is the same as result equals result plus results. Okay? It increments what the previous value plus something else. So actually you can, if you do this, this is the same as the increment with plus plus. It's exactly the same. You're saying your result is equal to result plus 1, which is 10 plus 1, which is 11. So another way of doing things. This also works for minus, of course. Right, this is also works, and it's the same thing. It will be 9. It's the same as the decrement. All right. So now that you understand those increment and decrement operators, let's introduce you to the math class. So math class, you see that is in Java-Lang, so you don't need to import it. It's importing it by default. And if you do dot, there are several methods here, like this is to do the power, for example, like 2 to the power of 2, it's like 2, and you have the power. So let's go again, int result, and this is a double, of course, it can be used results. So double, and now just print it out, the result. As in, you might know, this is 4, and it's basically 2 plus 2, 2 times 2. Awesome. So you have another functions, which is the round, and it takes a float or a double, so you can do 2.7, and let's go. It will be 3 because it will round to closest one, and if you open the round method, you have everything that you need. Return the closest to the argument which ties rounding to positive infinity. So yeah, it goes to the closest one. You have the round, sometimes you need to round it. You have the seal, and let's first read what it does. So returns the smallest closest to negative infinity. So it's pretty self-explanatory, right? So the seal of 2.7 will be also 3, but if you put 2.4, it should be also 3. It goes always to the upper bound. And then we have the floor, which is exactly the opposite. It should be always be 2. It goes to the lower bound. So if you do 2.9, it should go to the lower bound. And then you have the math.max, which gives you the max between two values. This is pretty self-explanatory. And if you run this, it should be 70. That's cool. Sometimes you don't need to do any of these operations, and you need to do some operations that require some randomness. So you have a method called math.random. Let's see what it does. Let's see. So returns a double value with a positive sign greater than or equal to 0 or less than 1. So it returns a random between 0 and 1. So if we run this, I don't know what it will be, but this is a random number. If we run this again, it's another random number. So imagine that you want to make a random between 0 and 100. You just need to multiply by 100, and don't forget, cast it to integer, right? So you transform a decimal into an integer, and then just declare an integer, and that's basically what you're going to do. And it should be something like, wait. So what do you think is happening here? This casting, it should be obvious, right? But it is not. So you are casting this math.random to integer, but since it's a number between 0 and 1 and it's decimal, it's always casting this to 0. So you're always making 0 times 100, so it's always 0. That's why you're getting always 0. So what we need to do is cast everything. So if we cast everything, our problem is solved. It should be a random between 0 . It was 0. I was just thinking, oh, this didn't work. Yes, it was really 0. It was a coincidence. So now we have a random number between 0 and 100 with 100 included. It works, right? So now you know how to generate random numbers, right? So we learned about what we learned about. So we started off with the arithmetic operators, right? Then we learned about the increment and decrement operators, right? And after that, we learned that math class has much more complexity and much more methods than this only arithmetic. It also does this. If we try, we can do like math.add, for example. You have all the methods possible here. You add subtract, you have everything. So, and what is missing? We are missing the comparison operators. So the comparison operators are really simple to understand. They compare something and they always return a Boolean. So the comparison operators are equal, equal. You might be wondering why two equals. I will tell you later. So you have the greater, smaller, greater than or equal, smaller than or equal, and that's it. This is weird, right? It should be something like this. But does this make sense? So if you do 1 equal 2, this is weird, right? This is the same as doing like int result equal math.random, right? Okay, double. You understand the point. So what's the difference? This might be strange for you, but this is actually an assigned operator. So it assigns to this result a value. So it shouldn't be used to compare. So that's why this is an assigned operator, and we need to have a different one. So we have the equal equal, which is the compare. So if you do 1 equal equal 1, it goes true. If you do 1 equal equal 2, it's not the same, so it goes false. As easy as that, right? So if you want to compare numbers or whatever you need, don't compare with this. Compare always with this one, not this. This is wrong. This is the assignment. This is the comparison, okay? So now that you know this, and we can just do something like int x equals 1, right? And we can do int y equals 1 as well. And if we do x equal equal y, it should be true. It needs to be true. See? If you do y equals to 2, it should be false, right? It is. Now you have the plus, the greater. So is it x greater than y? It should be false, right? Is it x smaller than y? It is. So it should be true. Now you have the less or equal, or greater or equal, and you can play with that. So you can do something like greater or equal. So it can be greater or equal. Since it's equal, it will work, it will be true, because it matches the equal. But if you do here 5, it should be also true, because it's greater than y. It is also true. The same one for smaller one or smaller or equal. It's the same. So that's basically the comparison operators. I hope it makes sense, and don't forget, always compare with 2 equals. Otherwise, it doesn't work in comparing primitives. There's also another way of comparing reference types, but it won't be covered in this tutorial. It's a different way of doing it, so it's not a beginner thing. Okay, so now we need to learn about logical operators, right? And that's what is missing. So we can have a boolean a. Let's call it something. I know Java is equal to true. Okay. And boolean I know C is equal to false. So if there are 2 logical operators, so the AND and the OR, logical AND and logical OR. So if we do I know Java or I know C, so you are saying, so this is like really, you can go literate with this. The OR is one or another, needs to be true, and the AND, both need to be true. So basically there is a table that you can use, and this is the like if it's true, and here is the OR. Okay, let me type it like this, OR. Okay, if it's true, it's true or true. Makes sense, right? I hope this is making sense. And now we have the AND. True and true, also true. Makes sense, right? Imagine that now it's true, false. So it's true or false. So this one is true, so only one needs to be true, so this will be true. And this one, it will be false because one and another. So not both. So now if it's false, true, will be exactly the same. So here it will be true, here it will be false. And the last one, if it's, let me extend this here. The last one, if it's false, false, here the or, it will be false or false, so you have no true value, so it will be false. And here it will also be false because one false and the other one is false. So you basically need to do, don't forget, both. So you can see the logic here. For example, here it's true and it's true, so it's always true. So if all the statements are true, and this works like you can have several columns, for the AND to be true, all of them need to be true. And for the OR, only one of them should be true. Needs to be true. So for example, you can like think like this, or if one statement is true, the outcome is always, it's always true. So you have the cases like this is true because one of those are true, one of those are true, so this is true. One of those are true, this is true. Neither of those are true, so this is false. The AND. If all statements are true, the outcome is also true. So if all statements are true, the outcome is true. So all statements are true, the outcome is true. All statements are true, the outcome is true. Neither of those, all statements are not true, so it's always false. Easy to understand, right? So now you know. So this is an OR, so at least one is true, so it should be true, right? But if you put an AND here, it should be false, right? But if both of those are true, it is true. But then if I make another AND, if I make another AND and put false here, it will be false, because not all of them are true, so it is false. So now you know how to work with logical operators, so don't forget about them. Logical operators are the I and OR, and we can also use them together, like you can do like this, and now you need to split your logic, right? So you need to split your logic like this. So this is true and this is true, so this is an AND, so the outcome is true. This is false and this is an OR, so one is true, one is false, Or if one statement is true, the outcome is always true. So this outcome will be true, and we can prove it. Let's run. See, it's true. You need to split, like make a tree and check the outcome of the one side, check the outcome of other side, and see the result. This logic will always apply. And that's basically it, guys. Those are the logic operators. It's half an hour in this session. I hope you learned a lot, and we are only missing session 4. And I hope you are enjoying the course, and I'll see you in session 4, last session. Hello everyone, and welcome to the last session. This is from previous class. Do you still remember this? So, session 4. Let's talk about session 4 and let's see what we have to learn in this session. So, let's talk about if statements, and of course, if statement, we also have the else. So, we are speaking about both of them. They work together, so there's no way of working with only if. You need to learn about the else. So let's also learn about switch statements. Those are not widely used, but they should be used when there are lots of ifs and elses. If you have in your code if, else, or if, else, you need to do a switch statement to make your code more clear and make your code more readable as well. This is those are part of the flow control. Why? Because you have an if block, you have a statement here, and if this statement is true, you go to here. You have an else, so if it's false, it goes to this piece of code. So this is a control flow because it goes to one part or to another. That's why it's called flow control. Okay, and then we have the for loops and while loops. So those are meant to do repetitive tasks, like for example for loops and while loops are good to iterate over an array. Imagine you have an array of integers like this and you want to sum all the integers, right? What you can do is iterate over them and just do 0 and go to position 0 plus go to position 1 plus go to position 2 plus go to position 3, and then you have the sum of all elements. So for loops help you do with repetitive tasks, because if you don't know the size of this array, you have no way of do this task without having for loops or while loops. And I'll show you that those have pretty different semantics, those loops, but you will get them pretty easily. So let's jump right into the code and see how it works. Let's go. All right, let's go. So this is from previous session. Let's delete this all. We don't need it anymore. And let's start with the if statement and else, if else, right? So for example, let's imagine that we want to make a roles system that manages roles and gives you different permissions by the role you have. So in this case, we are just going to print the role that you have. So imagine there are 3 roles. Admin, right? You can be an admin. You can also be a moderator, and you can also be a guest. So there are 3 roles here, let's see. So string role equals admin. Imagine that you actually are an admin, right? And so you can do something like if role, don't forget comparator, 2 equals admin. You can do something, right? Else, if role equals, what was the other one? Moderator. Moderator. You will print something or have your logic. Else, if role guest, you'll print something again. So now we can just have our logic here. So our logic might be like validations or whatever you want, but now just print and see where the code flows. That's why it's called flow control, right? Your role is admin. Okay, your role is guest and your role is moderator. Okay, so unsurprisingly, this should be printed out, right? Let's go and see. Okay, your role is admin. So if we change this to moderator, what do you think we'll get? Your role is moderator, makes sense, right? But now imagine that, and if you print, you place here your role guest, it will print this, your role is guest. But now imagine that you create a new role, right? And it is user. So is it admin? No. Is it moderator? No. Is it guest? No. So what will it print? Let's guess. I guess nothing. Nothing is printed. You can protect yourself. So against this, you can create an else without an if and just be smart and just do your role is unknown. Unknown. And now it will say your role is unknown because nothing is equal the role, so it will print your role is unknown. That's basically how if statements work. You can also make a shorter end, so you can make an if like this. You don't need to use those when you have only one line, but this is actually not a good practice in Java. I think it's make it less readable, and if you want to add another line, it will basically, it doesn't work. If you go now, I don't even know what it will do, but I don't think it will. Well, actually it works. I didn't even know that. But this is not a good practice to have, like, this is not a tab separator or indentation separation. It should be like with brackets. But now you know there is a possibility. If you want to have bad coding standards, you can do it by this way. If you if you remember from when we were beginning the session, I told you that when you have lots of if and else's, you should replace it by a switch statement, right? You remember that. So we have lots, I don't know, that's subjective, but you have like 4 statements here. You can replace them by a switch. Let's do it. Let's go. So switch. Here you want to switch over what? What do you want to evaluate? You want to evaluate the role, right? Open and close. That's it. And now you use the keyword case. So case, and it works like an equal operator. So case is admin, and you make like this, and you just do your role is admin. So easy, right? Okay, let's go. Case is moderator. You do something like this. Easy, right? Right. You are boring. You are being bored by me. And now you have the guests. Fair enough, right? We also have a keyword called default, which is equivalent to our else, final else, which is if nothing of this is true, just fall back to this one. So here we can print this one. What do you think will happen when we execute this? Can delete old code, and we are a user, so it should be your role is unknown, right? Let's see what happens. It worked perfectly, right? Now, if our role is admin, weird. Everything is printed. Why? Because it will always go to the other cases if you don't have a break. You need to have a break in all of them. All of them need to have a break. This is like... I actually don't totally agree with this, but it needs to be done. This should be enough, but no, you have to break to exit the switch. So now, if we do this, admin will be only printed out. So don't forget your break, never. If you forget your breaks, you will hit a wall. Okay, so now we learned about... What we learned about, do you still remember? We learned about the if, the else if, and when you repeat lots of those, just go, not a case, go with a switch, right? And a switch is like, this is equivalent to the if, this is equivalent to the else if, this is equivalent to the else if as well, and then if you scroll down, it will be equivalent to the else only. This is like fallback. Don't and never forget the break on switch cases. This is like almost 99% of the cases you want this. Don't forget this break. Okay, so now that we know the flow control, we can go to our loops, right? And we are going to learn about two loops: for loop and while loop. Those are different, but can do the same thing. But those are used for normally two different things, but you can, as I said, you can make the same tasks with both of them. The syntax changes, but they can do pretty much the same. Sometimes it's a personal preference. Sometimes you just need one of the other. But yeah, so let's delete our code again. So let's go delete our code. Let's go and delete everything. So let's start for the for loops, okay? And see how it works. So as I said, those are good to iterate over things. Things that it will be difficult for you to make without this, or even impossible. So if you have a string array of what do you want a string array about? Do you want about food? Okay, it can be food. you can have apple, it's food, right? You can have rice, and you can have meat. Let's go by meat. Okay. You initiate an array, like you already know this, right? So what is the length of this array? Should be easy, right? So this is the position 0 or the index 0. This is the index 1 and this is the index 2, right? So if you do food of 0, it should be apple. If you do food of 1, it should be rice. You understand the point, right? Let me just complete this. If it's food of 3, I messed you. It should be nothing because it doesn't exist. So what is the length of this array? It has 3 elements, right? So the length is 3. Easy, right? Okay. So let's continue. Imagine that you want to iterate over this. So for int, normally the variable in for loops is called I. You can call it whatever you want, just like a convention, right? So here, let me just finish and I will tell you what it means. Food dot length, and now an increment operator. Those are useful, right? And just do some system out I. Just this. What do you think it will happen? Let's see. We see 0, 1, 2, right? How does this works? So here you're like doing, I don't want this to, wait a second, I want this one, okay. Here you are doing like the start statement. So this is executed only when you're starting a for loop. So this is executed only one time, right? Here you have another statement, right? And you know this returns true or returns false, right? So I starts with 0, right? So is 0 less than the length, which is 3? It's true, right? So it means that you will enter inside of this code because this is true. If it's true, it will execute the code. If it's false, it will exit the loop and it will execute this code outside. So, and then you have the